My name is Tony Palermo. I'm a field application scientist with PerkinElmer. I've been here for about 9 years now and covered most of the Southeast. And I'm here to show you the Avio 550 Max. New addition to the fleet. We've added a high throughput sampling system with a valve system to pull sample to the nebulizer much faster. So we can get through samples, large numbers of samples in a day a lot quicker. Also, we're not putting as much on the plasma, so we're not contaminating our system as much. We're not putting sample through the peri-pump tubing. It comes with, you can opt for the S23. I've heard that it works with the CTEC as well, with back to the 560, I believe. And it's really just this system down here. And I'm going to zoom in on it for you so you can get a look at it. Can you see everything all right?
Yes, you're good.
Okay. So it should be zoomed in on. And down here, and I'll just remove the spray chamber here for you so you can see. Down here we have our sampling valve with a loop. That gets filled with sample through a vacuum port, which is situated down here underneath it. So this whole module will come in and replace the current peristaltic pump that you have on a 500, or it comes with the 550, the Avio 550. See, we have our peristaltic pump here, and that's actually going to move carrier, which you can't see, in the internal standard to the valve. And that's where we're going to do our internal standard mixing, and we're also going to push sample with the carrier through the valve, or through the loop, and out into the nebulizer directly from a very small distance, so it happens really quickly. Now I'm going to zoom out again so that you can see some of what's going on. Okay. Should be good. Can everybody see the top of the instrument? I can't see it for some reason. It's not showing up on my screen.
We can't see the top. If you zoomed out a little more, we could.
Okay.
A little bit more. Perfect.
All right. So, the Avio 550 has our proprietary flat plates, which we currently have in there. We run, drinking water applications at about 8 liters a minute of argon flow. We have a cassette here. This is fairly simple to remove. It drops straight down, comes out in one piece. Or while it's in there, you can actually take the injector out pretty simply, just to clean the injector. It pushes in, twists to the side, locks it in place. Also, the torch is just a screw nut here, and all of the fittings are plumbed through this cassette. So we put the torch back in, and we screw down the nut on top, like so. And that's it. There's no gas fittings or anything that actually need to be connected to the torch. It's just a slide in with a couple of O-rings on the inside, tighten the nut on top, and it's locked in place. So we're going to go ahead and put this back inside. There we go. Like so. And push the button, and we're in, ready to run. Spray chamber is fairly simple adventure. We have our locking tube here, and it just slips over the injector and the spray chamber like so, and we're ready to go. So what we'll do is we'll shut the top, and again, the top won't fall on you if you drop it, so that's good. It actually has a slow mechanism to prevent it from dropping down. So we've got the peristaltic tubing hooked up. We've got, I made a bunch of standards here to run yesterday, so we'll see how they go. And for now, we're gonna start up the instrument, and we're gonna use what we call it as an express run. Basically, what that does is we select a button, which is literally the first button in the software, and hit run. We're going to start the plasma in the same window, and I'll show that to you right now. Actually, I can switch between the two, hopefully. Screen one. There we go. So now I'm presenting. So we're going to go to this Express Analysis Quick Start button. And notice I have a method that came up because that's what I had loaded last. You could also go to the little File Open button to the right and open files as you need. You can open method, sample info file, and the data set. So I'm going to start the plasma here. Notice it turns green. We're going to get the plasma going. It's just going to take a second to purge. Let's see if we've got a status panel over here so you can see. So it's going to take another 15 seconds to ignite the plasma. It's going to purge out all the air that's in the lines. And if I can go back, now you should see the instrument again. And the plasma should be running in the window. You can see that it's on. It's adjusting itself down to 8 liters a minute. And now we're idle. And I'm going to go and share my screen again. And we're ready to analyze in about 5 minutes after startup. 5 to 10 minutes depending, but I'm going to go ahead and start this, and we're going to get the HTS system flowing. So we're actually going to have vacuum loading sample from the auto sampler into the loop. The valve will switch, and then we're going to analyze sample. So here we go. So you can see on the right, it's setting up plasma and everything for the method that was built. Notice method is located on the right, sample information file and data set are all loaded here. I'm going to go ahead and get rid of this because I'm done with it. And I'm going to go ahead and let you guys see what the auto sampler is doing. So right now it's loading the valve with sample. It just switched to inject. And now we're actually running the sample directly from the loop into the nebulizer after it's been mixed with internal standard. So it goes through a sample line rinse, then it waits for the analysis to be done, which is now. It's rinsing the loop. And you can specify how long you want to rinse the loop for. You can specify how long you want it to rinse for after it's done doing that. And then it goes to the next sample. And repeats the process over again. So we're just going to let it run for a little bit. I'm going to go through some new things within the software that are really advantageous to almost every lab. It's great. So let's go back and share my screen. Screen one. Okay. So some new things in the software. We've got our instrument panel This is actually, not very new. This is what we've had previously. This express analysis is fairly new. Our analysis window looks about the same, right? But within our method editor, we now have this really neat processing tab that allows us to do background correction automatically. So there is no need to adjust background points with this new system and the new software. It automatically will correct background for you. What does that mean exactly? Well, if we go to our results and we look at the spectra, notice how the background point, there's no background points within this spectra. All of these dotted lines are mathematically calculated in order to figure out where the correct background should be for each element. So that's actually a really neat new thing within the software that everyone will like, I guarantee it. Everybody remembers having to go through and adjust background points to make sure that everything, is set the right way. Make sure we don't have background points on top of other peaks on the outside of our peak of interest. So it's currently running, and it's about to run the next sample. We've got another ref, so you notice the background points have all been put in for you. And it's not taking into account these side peaks, which is great, right? So we don't really have to worry about background points anymore. One of the best things about this new software, in my opinion, one of two good things in this software. So that are my top two, I should say. The next thing that I'd really like to show you guys, other than in the analysis window, basically everything within here is fairly similar to our later versions. We've got this data viewer that we've added in a few years back, and it allows you to look at things inside an Excel spreadsheet. So what's new with that, right? Well, we've always had show RSDs, right? We've got replicates here. This is the new thing that I really like. You're able to pull up all the replicates for every sample just to see where everything is, okay? So if we go to concentration, you can't really see anything there. So we're going to go to corrected intensities for now. We're going to show replicates. And what we're actually able to see now, let me make this bigger, are all the replicates for the blank, for the internal standard above it. Notice all the replicates are located directly underneath the actual mean. So you're able to take a look and say, hey, what's happening with my HTS system? Do I have it timed right? There's a specific timing that goes along with all of these, high sample throughput techniques. So, well, how do I know that, we have the correct timing on there? Well, the replicates are one thing that'll show you if you have the correct timing. Is it too long? Is it too short? You'll start to see your replicates increasing if you don't have long enough for the sample to fill the loop in your timing. But how do we know where to start? There's another thing that we've added to show you the recommended time. Similar to our AA systems, where we have recommended conditions for running certain elements on the AA, we actually now have that in our method as well. So if you go to Sampler and under HTS, which is our high throughput sampling system, there are recommended loop parameter conditions. So for certain loop sizes, we'll be able to actually tell what the timings need to be approximately for our analysis. So I think what we've done is probably erred on the side of more time just to make sure that we have the sample there. And what you can do is optimize it yourself by looking at replicates. It really does help to check those replicates out. So in tandem, those two things work really well hand in hand. It's a very nifty thing that we've done. Right now, I can't look at them because we're actually running the method. So when this method's over, I will show you what that does bring up. So let's go and see where we are currently in the data viewer. We've got Oh, we're on our last sample already. We've already done a 4-point calibration, and we're running our third sample, and it's done. So it has just finished running all these numbers for us. And another couple of things to show you within this software here is we have new. Now these are standards I made yesterday, so I've got a little contamination because of the tubes they've been sitting in all night. But what I've got here are linear through zero curves on the right, and what you can see, you have sample IDs on the left, which is your standard calibrations. You've got your corrected intensities, and then you've got your concentrations that they're supposed to be and the concentrations that they are within the calibration curve as it moves through. And then what it has is a residual error now. So now it's calculating error on our curve after the curve has been made, so that we have that there to report to NELAC or any new regulations that come out that require it. So, and you can actually scroll through all of these calibrations here. You can export all the data into Excel from here as well with one click, which is actually a really nice thing that we're able to do. You can also clear the data here as well. But really the points to take home today, we have show replicates, which is really nice. We have our residual error that's been put into the software so that we don't have to go digging for it and redo it ourselves or anything like that. We've got the analysis, which is very nice. So we'll close this and we'll go to our process, our HTS, just so I can show you. We've got recommended loop parameters, so it brings up the help menu right here. So if your estimated analysis time is 5 to 20 seconds with a loop size of 0.5 milliliters, a loop fill time would be about 3 seconds, and we have a loop wash time of 1 second, and probably a read time of a half a second or less, probably like 0.25 of a second. So we're actually able to read for under 10 seconds, which is actually very fast. So we can go on these on the system. Probably I've optimized systems like this to about 12 seconds per sample, but that's without rinse. So you have to take that into account. But 25 seconds or so with a little bit of rinse, 20 seconds. Just spitballing it. You can kind of think about how fast you're going to get through samples running with this kind of system. So with that, I think I've pretty much covered a lot of the new stuff that's in the software. This is go back to the process just to show you one more time. The auto correction is there, but you're also able to do background points again as well. If you'd rather do it yourself, you can manually do it. If you want to have the software do it for you, you can do that as well. So, with that, I guess I'll take questions. It's been about 18 to 20 minutes.
Okay, Tony.
Kind of ran through some of that stuff.
I have some questions here for you. Does Avio use both nitrogen and argon? What gas is used for the spectrometer conditioning, flushing?
So with this system, you can use just argon if you choose. Now, granted, that's going to be a little bit more expensive in the long run because you're going to be going through a little bit more argon than normal. However, if you're not using it but once or twice a week, I wouldn't see that big of a deal. The only thing that's really going to go through it is the shear gas, and usually we'd use air for that because it's a lot cheaper. You can use nitrogen. What we use at our tech center is nitrogen for our shear gas. It's cheaper than argon. So we like to go with nitrogen, and then we have nitrogen for the spectrometer as well. And argon actually is bled over the detector to keep that from damage or harm. So yeah, you can have it configured pretty much however you want, but really the necessity in actually all cases is argon.
Great. And then the next question is, what is the name of the model which can be used for lube oils?
I would go with the Avio 500. It's a lot faster. You can absolutely use the Avio 550. You could absolutely use the Avio 220 as well. you know, the Avio 220 does go element by element when it runs, so it is a little slower. So if you're trying to do like a V23 mix and get all those elements all at once and do, you know, 150 samples a day, like a lot of lube plants do, you're probably better off with a 500 for sure to do them much more rapidly. So.
Great. And then what is the compatibility of consumables, torch, injectors, etc., with previous PE instruments like the Optima 830 or 8300?
Okay, so nebulizers are okay. Pretty much, sample tubing and all that kind of stuff is okay as well. The nebuli or the injectors and the torches and the spray chambers are all going to be new for the Avio 500. So you're not going to be able to go back to the other ones. We're not using those copper load strips anymore on this instrument. You know, the RF generator and the Tesla coil are actually a lot more powerful on this, so it doesn't need any of that anymore. So we don't need to, you know, put copper strips on our torches anymore. There's no hole in it, so you know, we don't do that anymore. So it makes it a new torch altogether. So yeah.
Great. And then what is the difference between OES and AES in the detector, or are these the same?
They're the same. They should be atomic emission and optical emission spectroscopy. That it's pretty much the same term. We're actually, you know, it's optical emission is basically done by this. It is the same thing as AES. So, in my opinion, so for these with respect to these instruments, so. It's just different terminologies for different companies.
Great. And then the last question we have is there a way with the software to print everything that is run during the day, even if you have to reset the sequence?
Sorry, say that again.
Yep. Is there a way with the software to print everything that is run during the day, or do you have to reset the sequence, even if you
absolutely. Have to? There absolutely is a way to do that. At the end of the day, you can go to the report system. It's called the data manager, and you just select the samples that were run within the day. You just give it a time stamp basically, and say I want to report all of the data that was done within, you know, today's date, and it will do that for you.
Great.
Absolutely.
And then we have a question coming in right now. Do you recommend a separate humidifier for high salt samples prior to the injector?
You know, it's sort of a sample. It's sample specific. If it's really high salts, yeah, I would recommend it. You know, there are nebulizers that can take care of high salts. Sea spray is specifically, and that's actually what I have on this system right here as well. It's a concentric nebulizer, but the tips of the nebulizer are actually burred, so they're kind of smoothed over, if you will. So that there's no edges, so that there's no place for the salt to deposit on it. But really, an argon humidifier does help in almost all cases when it comes to high salt matrices. Yeah.
And that's all the questions we have right now.